Hello everyone, I am Seshvidya, working as Associate Professor in the Department of Electronics and Communication Engineering at R.M.K College of Engineering and Technology. So today in Digital Electronics, we are going to discuss about decoders. So already I discussed multiplexer and demultiplexers and continuation. So what is decoder? So actually again this decoder is a combinational circuit and that converts n binary information to the maximum of 2 power n unique output lines. That is, one of this output will be active based on the combination of inputs present when the decoder is enabled. And this decoder, it is interrelated with the demultiplexer circuit. So what is demultiplexer? So demultiplexer is nothing but it's one to many. But here this decoder is nothing but n input data inputs to the 2 power n outputs. And at the same time, we shall have the enable inputs. So that is the difference between decoder and demultiplexer circuit. So next, in here it is binary decoder, that is 2 to 4 line decoder. So this binary decoder, it has n input binary inputs and one activated output of 2 power n outputs. So this binary decoder which will be used whenever it is necessary to activate exactly one of 2 power n outputs based upon the n input line values. So that's nothing but binary decoder. And this is the logic diagram for the binary decoder. And here it is inputs enable and two inputs A and B and outputs are 4. Why? Because we are designing 2 to 4 line decoder. So 2 inputs, 4 outputs. And here it is enable input. So enable is equal to 0. When enable is equal to 0, irrespective of the input terminals, that is input values, we'll be getting that output as 0. And once this enable input is activated, then which will take the inputs from the A and B terminals. So when both A and B is equal to 0, then we'll be getting that output as only that Y0 is equal to 1, the remaining outputs and all is equal to 0. So here it is the logic diagram. So that is only this first AND gate that will be enabled, so that we'll be getting that Y0 is equal to A bar, B bar. Second one, if A is equal to 0, B is equal to 1, then the second output Y1 will be activated. The remaining outputs will be is equal to 0. That is the second AND gate will be activated, so that we'll be getting that Y1 is equal to A bar B. When the inputs A is equal to 1 and B is equal to 0, then only this Y2 output will be enabled, that is Y2 will be activated. The remaining output will be 0, which means third AND gate will be enabled. And last AB is equal to 1. If both A and B are is equal to 1, then we'll be getting that output through Y3. That is the last AND gate that will be activated. So that we'll be getting that Y3 is equal to A. So next one is a 3 to 8 line decoder. So which has 3 inputs, namely A, B, C, and which will have the 8 outputs, that is Y0 to Y7. So based on the 3 inputs, one of the 8 output is selected. So these are all the inputs A, B, C and outputs are from Y0 to Y7. So based upon that input lines, one of the output terminal is selected. So suppose say for example, all three input terminals A, B and C is equal to 0, then Y0 will be selected, the remaining outputs and all is equal to 0. And then when A is 0, B 0 and C alone is equal to 1, then the second output terminal will be selected, the remaining outputs will be is equal to 0. So likewise, one of the output terminal is selected based upon the input values. So the corresponding logic diagram for the 3 to 8 line decoder. So when all three input terminals A, B, C is equal to 0, then Y0 is equal to, that is Y0 is selected. So that we'll be getting it as A bar, B bar, C bar. Similarly, we'll be getting that output from the one among the output terminals based upon the input. So next comes 4 to 16 decoder, that is 4 to 16 line decoder using 3 to 8 line decoder. So as we discussed in the demultiplexer, any larger demultiplexer or any larger multiplexers that can be designed by using the smaller multiplexer as well as demultiplexer circuit. So here also the same concept that can be followed for the construction of larger decoder using a smaller decoder circuit. So for example, 4 to 16 line decoder that can be implemented using, that can be designed using 3 to 8 line decoder. So how to implement this 4 to 16 line decoder? So let us discuss this one. So we know that 3 to 8 line decoder, it has 3 inputs. Say that as A2, A1 and A0, and which will have the 8 outputs from Y0 to Y7. Whereas in case of 4 to 16 line decoder, which will have 4 inputs, say that the inputs as A3, A2, A1 and A0, and which will have the 16 outputs, that is Y0 to Y5. So what is that formula to find out the number of lower order decoders that is required to construct this larger decoder is, so here there is a formula, required number of lower order decoders is equal to M2 by M1. So M2 is nothing but the number of outputs in case of larger thing, that is 16. And the smaller decoder which will have the 8 outputs, so 2. So therefore we require 2 3 to 8 decoder for implementing 1 4 to 16 decoder. So likewise we can able to find, so what is the type of the lower order decoder that has to be used for implementing larger decoder circuits. Implementation. So this is a corresponding logic diagram, and for we'll be using through 3 to 8 line decoder to construct a 4 to 16. So since it is in 4 to 16 line decoder, so which will have 4 inputs and 16 outputs. So based upon this enable inputs, when this A3 is equal to 1, then the first decoder which will be enabled, so we'll be getting that output from Y9 to Y15. And here at the same time when E is equal to 1, then and this is enabled, at the same time this will be disabled. So similarly when A is equal to 0, then the upper decoder which will be disabled and the lower decoder which will be enabled. So we'll be getting A, that is one among the 2 power n output lines. So this is a corresponding truth table for the 4 to 16 line decoder circuit. So next one is implementation using decoder. So for example, question is implement the full adder with a decoder circuit. So we know what is full adder circuit. So first we should write a truth table for full adder. So the three inputs X, Y, Z and outputs are sum and carry. So from the truth table we can able to write what is sum is equal to in terms of SOP form. So sum is equal to SOP 1, 2, 4, 7 and carry out is equal to sum of product terms 3, 5, 6, 7. Now we know that decoder circuit, so we can just implement. So this is the implementation diagram. So we'll be using 3 into 8 decoder. So which means which will have 3 inputs X, Y, Z as that of the full adder and which will have the 8 distinct output and this 8 distinguished outputs, that is from 0 to 7. So what is that sum? So sum is equal to, it's in sum of product term of 1, 2, 4, 7. So we'll be using the target. So 1, 2, 4, 7 that can be connected to the input of first target. So what we are getting, that output is nothing but sum. And similar way 3, 5, 6, 7 that can be connected together as an input to the second OR gate. So output will be carry out. So likewise any combination logic circuit that can be implemented using. So next comes implement with a decoder and external OR gate the combination circuit specified by the following 3 Boolean functions. So they are given 3 Boolean functions that has to be implemented by using decoder circuit. So how many input terminals? 3 input terminals, that is 3 variables. So we'll be using 3 into 8 decoder. So what are the variables? A, B, C. Here if you want you can just write it as A, B, C. So we can just implement all 3 functions as it is. So let us consider this is F1, F2, F3. So we'll be using 3 OR gates here. F1. So what is that F1? It's in a sum of product term of 0, 5, 7. 0, 5, 7. That will act as an input for the first OR gate. And the output is nothing but function 1. And what is the second function? It's in sum of product term of 2, 3, 4. So 2, 3, 4 that will act as an input for the second OR gate. So therefore F2. Similar way F3 is nothing but it's in sum of product term of 1, 6, 7. So 1, 6, 7 that will act as an input for the third OR gate and output from the third OR gate is nothing but F3. So likewise you can able to implement any using decoder circuit. So if you're just coming into that what is it application of decoder is, and this decoder circuit so that can be used and whenever an output or a group of output is to be activated only on the occurrence of specific combination of input signal. And one more thing is this decoder that can be used as in timing or sequencing signals to turn the device on or off. at a specific timing interval. And most popularly, it is used in code conversion, that is analog to digital conversion in the analog decoder. It can also be used for the data distribution, as I told you. Okay, so therefore the decoder that can be used as an address decoders in case of CPU memory location identification. Okay, thank you. I hope you understood the concept of decoder. Thank you.